Let's take a look at this problem number 9 from the May 2016 release version of the Algebra 1 STAAR test. And let's go ahead and read. The starting annual salary for an office worker at a company is $29,000. If the company awards an annual increase of 6.2%, which graph models this situation after the office worker receives X annual increases? Okay, so this problem here is describing a exponential function. So there's two types of exponential functions. We have exponential growth functions and we have exponential decay functions. Okay, so because we're getting an annual increase each year, this is going to be a exponential growth function. Okay, so let's go ahead and start building our function. Let's call our function S for salary, and our input's going to be X value. X is going to be X. Okay, equals, and then we start with our initial salary. Okay, so the first part of the exponential function is going to be your initial or starting value. Okay, so we're starting at 29,000. Okay, and then our next factor is going to be the exponential growth factor. Okay, so what we have here is we're going to have an increase of 6.2%. Okay, so what we want to do is we're going to take 1 plus 0.062 and add that together. Okay, that's going to be our base of our growth factor. Okay, so that gives us 1.062. So we're going to put that into our parentheses here. Okay, and then we're going to have an exponent of x. So each annual increase we're going to get, we're going to raise it to that power. And this is going to give us our exponential growth or salary increase. Okay, so let's go ahead and let's take a look at a few of our answers here. Okay, so starting, our initial salary is $29,000. Okay, so looking at our answer choice A, looking at the graph, it looks pretty close to 29,000. Okay, so if you look at answer choice B, and that one also looks pretty close to 29,000. So if you look at answer choice C, we can clearly see that it's around $5,000. Okay, so our starting salary is $29,000. So we can go ahead and mark that one out. And if you look at answer choice D as well, it's starting at $5,000. So let's go ahead and cross out answer choice C and D. So now we're down to 2 answer choices. So let's go ahead and evaluate our exponential function after 1 annual increase. Okay, so we're going to take our function and we're going to solve S at 1. Okay, so we're going to replace X with 1, and we're going to have 29,000 times 1.062 raised to the 1 power. So anything raised to the 1 power is, as long as it's not 0, is whatever that number is. Okay, so we have 29,000 times 1.062. Okay, so let's go ahead and put that into our calculator, and we have we end up with 30,798. Okay, so after our first annual increase, our salary goes up to 30,798. 798. Okay, so let's go ahead and look at our answer choices that we have. So after 1 increase, this graph looks like it's at least almost 25% of in between 30,000 and 35,000. Okay, so let's look at our other answer choice, which is it shoots all the way up to around 45,000. So that is well above the 30,798 that we just calculated. So it looks like B is not going to be a good answer choice. Looks like it's pointing to A. So let's go ahead and check after year 2 and see what we get. Okay, so we take our function and we're going to evaluate it at 2, and we have 29,000 and then 1.062 to the 2nd power. Okay, or 1.062 squared. Okay, so let's go ahead and evaluate that using the calculator, and we find out that the salary, our new salary is going to be $32,798. 70750. Okay, so let's go back, which is still well short of the what looks like 45,000 after year 2. We're still short of that number. Okay, and at year 2, according to this one, it's off the graph here, so it's looking like it would be almost probably $80,000. Okay, so we can go ahead and feel pretty comfortable ruling out answer choice B. Okay, so that leaves us with answer choice A as a correct answer. Okay.